So, what if you actually fell into a black hole? I mean, really think about it. It's one of the most mind-bending questions in the entire universe, and it pushes everything we know about physics right to the absolute edge. In this explainer, we're going to find out exactly what would happen.
You'd think that's a simple question, right? Can you go in, yes or no? But the answer is, well, it's one of the most complicated and fascinating things in all of science. We've all seen them in movies, but what would really happen if you took that final plunge?
So buckle up, seriously. We're not just going to talk about black holes today. No. We are actually going to take a trip into one. Think of it as a first-person adventure to the very edge of reality itself.
Okay, first things first. Before we dive in, we got to know what we're up against. So what exactly is a black hole? Well, it all starts when a really, really massive star dies. It collapses in on itself and creates something with a density that is almost impossible to imagine. This analogy, it absolutely nails it. You take a colossal amount of mass and you squish it into a ridiculously small space. That extreme, unbelievable density is the secret sauce. It's what gives a black hole its absolutely insane gravitational pull. And this leads us to a really wild concept called the Schwarzschild radius. It's basically the tipping point. If you could squeeze any object down to this specific critical size, it would become a black hole. Mount Everest has one. Heck, you have one. The only difference is, for a giant star, its own gravity is powerful enough to actually do the squeezing.
All right, our ship is ready. Let's begin the trip. From way out here, a safe distance, a black hole just looks like, well, nothing. A perfect patch of blackness punched out of the starry background. But as we get closer, oh boy, things start to get weird. Very, very weird.
You see, a black hole's gravity is so powerful, it doesn't just pull on stuff like planets and stars. No, it literally bends and warps the very fabric of space-time itself. And this means it bends the path of light, creating these bizarre, distorted views of the universe around it. It's like a cosmic funhouse mirror. And this crazy effect, it actually has a name: gravitational lensing. Light from galaxies that are millions of light years behind the black hole gets twisted and smeared into these incredible arcs and rings of light. So what we're seeing isn't an object, but more like a ghost of light that's been bent all the way around it to get to our eyes. Wild, right?
Okay, we're pushing in closer now, entering a region where the laws of physics as we know them really start to fray at the edges. This is the zone where light itself can get trapped in orbit. We've just hit a spot called the photon sphere, and this is where things get trippy. The curve of space-time here is so intense that photons, particles of light, are forced to just circle the black hole. Now get this, if you could just hang out here for a second and look to the side, light from the back of your head would travel all the way around the black hole and arrive right back at your eyes. I'm not kidding, you could literally see yourself from behind.
And it's not just space that's getting warped. Time is too. Let's say your friend is watching all this from their ship at a safe distance. To them, you would appear to slow way down as you get closer. Eventually, you'd seem to just freeze right at the edge and then slowly fade away. Your friend would never actually see you cross. But for you, nope. On your ship, time feels perfectly normal as you sail right past that point of no return.
And that brings us to it, the main event. The boundary that has defined black holes in our imagination for decades. We are about to cross the event horizon.
Now, the event horizon, it isn't some physical wall you'd crash into. It's more of an information boundary. It's the precise point where gravity becomes so crushingly strong that the escape velocity is faster than the speed of light. And since nothing can go faster than light, well, once we cross it, there is no turning back. Our fate is sealed.
And we're in, we've crossed over. Looking back is, well, it's bizarre. The entire future history of the universe is now compressed into a tiny, brilliant point of light behind us. But we can't look back for long, because our journey now only has one direction: forward, toward the center.
So what happens now? Well, as we drift towards the center, the singularity, gravity gets intense, but not evenly. The gravitational pull on your feet becomes exponentially stronger than the pull on your head, even over the tiny distance of your own body. This tidal force, this incredible difference in gravity, starts to pull you apart. And this whole process has one of the absolute best names in all of science. It's not just stretching, it's called spaghettification.
Yep, spaghettification is exactly what it sounds like. Your body would be stretched longer and longer and compressed thinner and thinner from the sides until you're literally a stream of atoms flowing into the singularity, a strand of cosmic spaghetti. Yeah, it's a pretty gruesome end, but you gotta admit, it's fascinating.
Okay, so our personal journey is, well, over. But the story of black holes, it is far from over. These things aren't just cosmic vacuum cleaners. They are fundamental forces that actually shape our universe. And they hold some of its deepest, darkest secrets.
The truth is, this is where our current understanding just stops. At the singularity, our laws of physics break down completely. We know that supermassive black holes, these absolute monsters, are the anchors that hold entire galaxies together. We know, thanks to Stephen Hawking, that they can slowly evaporate over billions of years. And some theories even suggest they could be gateways or wormholes to other parts of the universe.
And that leaves us with the ultimate question, doesn't it? For anything that falls in, a black hole is a definitive end. But on the grand cosmic scale, are they just recycling plants? A place where one story ends so that another one can begin? It's a question that just reminds you how much of this incredible universe we still have left to explore. Thanks for taking this trip with me.